Yes, am I audible? Austin, Faiza, Humam, Tarif, Rabah, Rabia, Shahid, Chavez.
Yes.
All right. So in the last class, we had started with series and parallel combination of resistors, right? So we had seen that the series combination of capacitors and parallel combination of resistors, they have the same formula. That means you reciprocally add them. And what we had seen next thing was parallel combination of capacitors with series combination of resistors. They had the same formula that you just have to directly algebraically add all the values of resistors or capacitors given. Some circuits also we had seen. Infinite series also we had seen. In infinite series, you identify the repeating term, you add one more repeating term, which becomes equal to R equivalent. And then you solve normal quadratic equation, you obtain, and values of resistances obtained. Now see, certain questions you will find where you are not able to identify whether it's series combination or parallel combination. One method that we discussed is by seeing current. If you seeing current is same, series combination. If you seeing voltages are same, parallel combination. But sometimes you are not able to identify whether it's series combination or parallel combination. So full proof law you have, that is known as Kirchoff's law, which is valid for any circuit, whether it's a very small circuit with a single resistor or a very huge complex circuit you are having. So Kirchoff's law is applicable. Two laws are there. First law and second law. First law, we call it as the junction law. So algebraic sum of currents at any junction is zero. This is what is meant by this law. It means, for example, certain sets of resistors I am giving to you. This is the junction. This we call as the junction where the branching is occurring. Now look here, class. Suppose from here, I1 current is coming. Let's say from here, I3 is coming, is leaving the junction, right? Or let's say here, different junctions are made. And this is also exiting. One current is entering from here, that is I2. This is going from here, this is leaving this is I3. Now, all the currents that are entering your junction will be equal to all the currents that are leaving your junction. Now, I1 is entering, I2 is entering. So, for the currents which are entering the junction, we will write it as positive. Like you can see, current I1 is entering over here, right? So, that is plus I1. I2 is also entering. So, you can say plus I2. If you are leaving this I3, if you are leaving this becomes minus I3. Suppose this is leaving. I have written both them as I3. No, make one as I4. हाँ, ये वाला है I4. So this also leaves. So this becomes minus I4. Means your total current, you can see algebraic sum of the currents at any junction is zero. So this law will be applied. You will see how to apply all these laws, but basics of these law you should understand. Now what you can conclude, whatever current is entering the junction is actually equal to current leaving the junction. This is what is meant by Kirchoff's junction law also we say. We call it Kirchoff's current law also. Kirchoff's junction law or Kirchoff's current law. Now second law of Kirchoff says that voltage is zero. Means any closed loop. If suppose a circuit is made and if you have a closed junction, then we say around at that particular closed junction, in your Kirchoff second law, the voltage is zero. So first law involved your current. Second law involves your voltages. So all the voltages should be zero. That is what is meant by it. Suppose this is a cell I'm giving you. This is positive terminal. This is negative terminal. Current is entering over here. So in this case, your potential will be positive. We have to apply all the sign conventions here. Let's say this is current is, let's say, coming from this I have discussed in the last class also, that discharging and charging. Remember when we were discussing terminal potential difference? So if your current is coming from the negative and entering the positive, then we have potential as negative, minus E. Minus of EMF you will take, negative. These are the certain sign conventions we have to follow. I will tell you all the sign conventions, because without the sign conventions, you'll not be able to solve any of these. But do one thing, note down these, then I will, or let us discuss the law and we will practice this question. This is from your NCRT, an important question it is. This is a question from your NCRT, we'll discuss it. But let me tell you how to begin it. Firstly, wherever you see this case, means current is going from the positive terminal, you will mark it as positive. Yes, Chavez, I'll repeat. See, firstly, I am repeating it. Currents, junction law says that whatever current is entering the junction is equal to current leaving the junction. Let's say I1 and I2 have entered. So I3 and I4 are exiting. So I1 plus I2 is equal to I3 plus I4. This is one law. Second law says that voltages are zero. Means around any closed loop of a network, algebraic sum of changes in potential is zero. Is zero. This is actually changes in potential, means change in potential. This is actually zero. That is your Kirchoff's voltage law, KVL. Once you apply KCL and then we apply KVL whenever we'll solve circuit. So first thing you have to remember this. This is important for your sign convention. Now we will choose a loop. A certain loop we will choose. There, if you see, if we are moving along the direction of current, I will tell you how. Suppose a resistor, you are encountering a resistor. Current is moving like this. So see, remember, current always moves from higher potential to lower potential. It means this is plus, this is minus. So if suppose in my loop, I am moving like this. Suppose I am moving like this. So if you are moving along the direction of current, then negative current you will put negative current. The sign convention will be negative. This won't be cleared just like this. We have to solve through with the help of example. Suppose we are moving opposite. This is the direction of current. Current is moving towards right. We are moving towards the left. The loop we have chosen, the sign convention we have chosen, we are moving in the opposite direction. So if you are moving opposite to the direction of current will be positive. These 2 points, this point and this point, these 2 points will be helpful in the solving of your Kirchoff's question. So these are for your numericals purpose. I'll discuss it right now. With just looking at this, you'll not be able to understand anything. But these 2 laws can come separately to write, and they have already appeared in your board exams also. Kirchoff's first law and Kirchoff's second law, you have to mention the laws also. So mention it, then I'll tell you how to apply. We'll practice that NCRT question. Through that, you'll be able to understand construction of the loops, finding voltages, finding current. Note it from here. If you have any doubts, you can text me in the chat column while writing also. Shayad, I'll send you the link of of yesterday's video. Series and parallel combination we had started no on Thursday. So series combination we had completed on Thursday. Yesterday we had completed the parallel combination, certain registers, circuits we had seen, and infinite series case. So do look up the video, and if you have any doubts, then let me know. Now, see, we'll apply all these what we have studied above. 3 loops you can see. A, B, this is C, this is D point. Now see, we will consider loop wise loop we'll go. A, B, C, A. Let's consider this loop. See, if I just write A, B, C, that means from A to B, B to C. I have to complete the loop. So I'll write C to A as well. So A, B, C, A. That is the complete way how to write it. Right? Now, look here. What we'll do, one by one, we'll come here. Let's say one direction of current, randomly assume it. Randomly, you have to assume the direction of current. Let us just divide the current and one by one you can flow, make the current flow. Let's say from here, I1 is moving. From this, I1 is coming. Let's say into this branch, I2 is moving. This you can divide on your own. I2 is going. So if I1 was coming, I2 has left. How much is left now? I1 minus I2 means in this branch, I1 minus I2 is moving. Right? Now see, from here, I2 is coming. Then let's say in this branch, I3 is moving. Right? I2 is coming. Then in this branch, I3 is moving. So you can check into this branch, how much will go. Right? Or let's say not into this. Let's reverse this. Wait, just wait. See, here, let's say from this battery, I3 current is moving. Let's say from here, I1 is moving. So you can distribute the current by yourself. I1 is going, I2 went here. Now I1 minus I2 went into this branch. From here, I3 is coming. So total into this branch will become I2 plus I3. Yes? From here, I1 left. So how much will go here? I2 plus I3 was coming, I1 left. So I2 plus I3 minus I1. This is coming into this branch. Again, now I1 minus I2, I2 plus I3 minus I1 comes. How much will be left? Again, I3 will be left. So you can check. Entire current has been divided. You can distribute it anyways. Start in a, you can make this as I1, then make in this branch I2 is going. Anyways, you can take this. This is the liberty of Kirchoff's law which you have. You can take any of the circuits, any distribution. It's just that you have to check in every wire, same current has to flow. So for example, from here I2 plus I3 is coming. If I1 left, this much is left. When I have added this and this, I am left with I3, means I am getting my current back. Right? So I1, I2, I3, all the currents I have divided. And try to minimize the number of variables which you have. This is the method to use Kirchoff's law. Suppose consider this loop ABCA, which I was discussing with you. The loop ABCA. Now let's take one direction. Suppose let's move clockwise. Now moving clockwise, we are moving along the direction of current. Yes? What did I say? When you are moving along the direction of current, we put a negative sign. And how do we write the voltage? V is equal to IR. See, this is what we have distributed. We have used the Kirchoff's junction law. We have distributed the current. Whatever currents are entering are leaving. This is Kirchoff's current law has been applied. Now coming to Kirchoff's voltage law. What did we study? That net voltage is 0. So what is the voltage here? Voltage is 4 into I2. And why minus sign? Because we are moving along the direction of current. Next, here again we are moving along the direction of current. Current is I2 plus I3. Resistance is 2. So this becomes 2 into I2 plus I3. See, we were moving along the direction of current. Clockwise we are going. Here, this will also become minus 1 into I1. And look here, this I have told you. When you are moving from negative terminal to positive terminal, we take it as plus. So this is already voltage. So we will put it as 10 equal to 0. So our first equation has been constructed. This is how we solve all these and this is how we get the equation. Understood? I'm repeating this. What did we study above? I'm telling moving along the direction means This is the direction of current that is written using Kirchoff's current law. We have distributed the current. So I2 is in this branch, right? Now, when I'm saying moving along means, suppose I am taking the direction as clockwise. So how will I move clockwise? Like this. So that is moving along the direction of current. Suppose in this question, this part only, I chose to move anti-clockwise. So I will move in the opposite direction of current. So in that case, I'll take it this as positive. You can take any direction, you can take any variable, all the answers will come zero. It's just that in every branch, you should get the values of current. It can be variables, can be different according to you. How you have to answer? You have to answer in terms of branches. Like suppose this is my I2. Suppose Chavez, you have taken I1 in this branch. So your I1 value and my I2 value will be same. Ultimately, we have to use and find out the value of current that is present here. So like this, we have solved this loop. Coming to this loop, let me move anti-clockwise. Now look here. Let's say the loop is this loop. This loop is A, C, D, A loop. Means this complete enclosed loop. Now randomly I have taken opposite side. You can take any direction. I am taking anti-clockwise. Let's move from here. So I am moving anti-clockwise. So firstly this comes, current is I1. So we are moving along the direction of current. So if we are moving along the direction of current, this becomes negative. So minus I1 we are having. Again, from negative terminal to the positive terminal we are moving. So we will put plus 10. So this branch is done. Now moving anti-clockwise. Again, we are moving along the direction of current. So it will be negative 4I1 minus I2. This is how we take. And look here, this was what you were asking, Chavez. See, we are moving like this now to complete the loop. This was the direction anti-clockwise. Like this, we will move anti-clockwise. Look here, we are moving opposite to the direction of current. We are moving opposite to the direction of current. So we will take this as positive. That is 2I2 plus I3 minus I1. This was the current. Net is equal to 0. See, when we distributed the current, that was Kirchoff's current law. And when we are writing all the voltages equal to 0, when we are writing all the voltages equal to 0, your, see, V is equal to IR. V is equal to IR. And this was already voltage, so we wrote it as 10. Did you understand how to construct it? See, these equations you can solve. In any ways you can solve. Later also you can solve this. Firstly, how did we apply? How did we distribute it? And see, this is one equation. This is second equation. I need one more equation because we have 3 variables. So we have 3 variables and we need 3 equations minimum. So what we will do? We will construct one more equation because we have one more loop over here. So we can choose that loop and answer, right? I will just discuss how to write the equations with you, because solving the equations all of you will be able to do. But this can be confusing in the starting. It actually becomes very confusing in the starting. In second equation, we should add voltage also. Yes, you will add voltage also. See, everything we are adding, this is voltage, Shahid. See, this is also voltage. This is also voltage. This is also voltage. Minus I1 into 1. Resistance is 1, current is I1. So voltage becomes minus I1. Here voltage becomes 10. Here voltage becomes current. This is resistance into current. So we are adding the voltage. Okay? Yes. See class, I am again repeating before we write the last equation, because you just have to understand these writing of equations. Rest solution part is very easy. All of you will be able to do. And in the starting, it becomes very confusing, because division of current becomes confusing. How to divide the current? So randomly start, randomly. I just started randomly. I just named this as I1. I just started it randomly. I just named this as I1. I1 went here. So I just took that, let's say I2 is moving in this branch. So what will be left then? I1 minus I2 will be left. We have to have the minimum variables which are possible. Because if you have more variables, you have to find out more equations, you have to do lots of calculations. So to prevent that, best way is directly take the currents, minimize the values of currents. So I1 minus I2 is left here, right? So I1 is here, I1 minus I2 is here. And then I took C. Till here I stopped. Then I noticed that one more battery is existing. So from here I3 is moving, one more variable will be needed. See, if I2 and I3 are coming at this junction, both will get added into this branch. That is I2 plus I3. And I have already taken I1 in this branch. So it means if I2 plus I3 are coming, I1 must have gone from here. So what will be left? I2 plus I3 minus I1. You can notice, see, from this branch, I1 minus I2 is coming. From this branch, I2 plus I3 minus I1 is coming. What is left? We are getting I3 back with which we had started. If you are seeing all the values of currents, they are getting divided equally, they are dividing properly. You can take any variable, you can make this as I1. We don't have to answer everything in terms of I1, I2. We have to answer in terms of branch. Suppose, let's say I have taken I2 plus I3 in this branch. Let's say one student, let's say Austin. Austin has taken I1 in this branch. My I2 plus I3 is coming 5 amperes. So Austin's just I1 will come 5 amperes. Means whatever variables you take, that doesn't matter. Your branch should have the same values of current. If I am calculating, my answer is coming 5 ampere. So I2 plus I3 is 5 amperes for me. For Austin, if Austin has taken 1 amperes, Austin has taken I1. So Austin's I1 should come 5 ampere. Mean ultimately at the end, we have to have the branches having the same current. So do not worry about these currents division. Randomly keep on dividing it. Then we consider one loop. This class, we'll just try to discuss Kirchoff's law only. Whatever time it takes, it doesn't matter. We are towards the end of the syllabus, towards the end of this lesson only. But please understand this, how to solve this. Suppose this was a loop I have taken. Now, once you have divided all the currents, you have obtained all the different values of currents. You have applied Kirchoff's current law. First, tell me, this distribution of current, Kirchoff's current law, that is Kirchoff's junction law, is it clear to all of you or not? Then I'll discuss this again. Yes, no. Yes, Faiza has understood. Only Faiza has understood. It's clear. Okay. If this current portion is clear, then it's very good, because that is also the basic for your circuit drawing. Now, once you have divided the current equally, your job is to apply the second law. First law we had studied was Kirchoff's junction law. So we have divided the current, we have applied this law successfully. Second law says that net voltage should be 0. Suppose a voltage is given, so just put the voltage. Suppose a resistor is given, so you know resistance, you know current that is flowing. So V is equal to IR, you can get voltage here also. Your purpose is to write the net voltage as 0. That is your purpose. Your purpose is to write net voltage as 0. So see, in this loop, and you have so much liberties in this law, no, so much. It's just that you have lots of benefits from this law. First benefit is that, see, if I give you this circuit and I ask you to solve it, you will not be able to solve it, because you cannot find whether anything is connected in series or parallel. This seems that they are in series, this then appears they are in parallel again, and once you look, then entire appears in parallel. So this becomes very confusing, right? Whether it's series or in parallel. So this best method you can check, a basic simple circuit is also given. Now that also you can solve with the help of Kirchoff's law. Secondly, you can randomly put the currents. You just have to distribute them equally. So currents direction also, this can be substituted. So you have the liberty in that also. Third liberty, you can take any direction. Clockwise you can move, anti-clockwise you can move, because these are simple sign conventions, so ultimate answer would be same. So this is also the disadvantage of Kirchoff's law, which I also find it very irritating, is that it is very lengthy. It's very lengthy. You can see these three equations till here, first the division of current and then solving these equations. This actually is a tedious work. That's why I try to avoid whenever, if I have a circuit to solve, I'll first try to solve it using the formula. But if I get stuck somewhere, then I apply Kirchoff's law and then the answer is solved. But just the disadvantage of this, which is the biggest disadvantage, is that the calculation part becomes lengthy because you have to actually solve 2, 3, sometimes 4 equations also, depending upon the number of variables. Sometimes only I1 and I2 are included. So 2 equations are enough. I'll show you a question where 2 equations will be sufficient. This is actually an example or a back question from your NCERT. That's why I wanted to discuss this. Now, but you have advantages also in your exam. If you get stuck anywhere, you are not able to identify whether it's series, parallel, you can go to Kirchoff's law. And sometimes questions are there which specifically demand to solve it through Kirchoff's law. But if nothing is mentioned and you just have to find out the answer and you can solve it using formula, try to go by the formula, because this will consume a lot of time solving these equations. Even in the class, I do not solve this equation because the time gets lost a lot in this. Yes, so coming to this, but again I'm repeating, this is the part of your syllabus only, so practice it. If you practice, you will be able to divide the currents automatically. Initially it becomes difficult. In which branch you have to take which current, and try to minimize number of variables. So see, I have taken this randomly as clockwise. When I'm taking it as clockwise, I will move it like this. This is clockwise. So here I am going along the direction of current, along the direction of current, along the direction of current, from negative to positive. This is negative, this is positive. This is how I am moving. So 4 into I2, that becomes potential here, and sign convention, along direction of current is negative. So minus 4I2. Again, this is along direction, so negative. Along direction, so negative. And from negative to positive, plus 10. Similarly, in this branch also, I have taken this as randomly. Let's say I have taken this as anti-clockwise. So anti-clockwise means moving like this. So all of them are towards along the direction of current. This is opposite. So that's why only this was positive. Before writing down the last equation for I3 for this loop, tell me, is it clear to all of you till here, or any doubts, or you want me to repeat any equation, any part? Is it clear or not? Yes or no? It's clear. Okay. Very good. Then coming to the last equation. Let me take it again random. Let me take this as clockwise. Let's take it as clockwise. So see, this is positive terminal, this is negative terminal. Now I am moving from positive terminal to the negative terminal, right? Current is coming from here. This is the direction I have chosen. So here I am moving anti-clockwise, no? No, this is clockwise. Here opposite to the direction of current, here opposite to the direction of current. So if they are opposite to the direction of current, means both will be positive. In this branch, let me make the loop name. Loop is B, C, D, B. So 2 plus 2 we will take. What is the current? I2 plus I3 minus I1, because we are moving opposite to the direction of current. Again, opposite to the direction of current. So this becomes positive. So 2 into, what is the current in this branch? This branch has I2 plus I3. So this will become I2 plus I3. Now, lastly, you have the cell. See, in the cell, current is moving out of the cell, right? What did we study? If we have this case, when the current is moving from the positive terminal, we write it as positive. Yes, until now we haven't encountered this case anywhere, yeah, in this circuit. This was the only case. So again, this will be positive. So plus 10 it is equal to 0. 3 equations you have, 3 variables you have that you can solve later. Note it down. Again, let me know wherever you are having any doubt. I will discuss one more question with you, which is a little easier than this. In that question, you all are going to answer. That's why I'm telling. Please clear your doubts in this questions. Note it down. You can text me your doubt. Yes, I'll explain. See, Faiza. Regarding the battery, regarding cell, a long direction and opposite direction was for current. Regarding the battery, see, look at this battery. Oh, not sorry, not 10. This is 5. That won't be 10. This is 5. This would be plus 5. Earlier we had 10, no? हाँ, यहाँ पे 10 होगा. Niche it would be 5. See. Now look. If you are seeing in your circuit, current is moving from positive terminal. Like here it is also moving from positive terminal. It can also happen, no, current is moving from negative terminal. So you have to look at this. For battery, best way is to look at this. Whenever you see current is moving from positive terminal, V is plus E. If current is moving from negative terminal, entering into the positive, moving from negative, then you have to take minus E. So in both the batteries, we were having this case. That's why plus 5 and plus 10 was considered. Plus 5 and plus 10 were considered. Clear, Faiza? And yes, I wanted to discuss one thing. You people have scored so less in the last test. Why? Austin, Shahid, Tarif, Rabia, Humam. These 5 students have only appeared first thing. Faiza, you didn't appear for the last Friday's test. Raba was new that time. Raba.
I did, ma'am, I did.
No, not this Friday. Last Friday. That time you weren't there. This Friday, I haven't checked your papers. I wanted to discuss. Rabia has attempted. Shahid did. Shavez, what is happening? Why you are not attempting the tests? Acha. ठीक है Faiza. I want to discuss this. Why the scores were very less? Austin, Shahid, Tarif, Rabia, Humam. Shahid is 18.5. See, this last time you had the test on current electricity. Before that, this test I'm talking about capacitors. Yes, capacitors portion which come. You people have a habit of just skipping to the answer and writing it in one line. Class, in this case, no, in your JE entrance, NEET entrance, all the entrance, CUET, whatever entrances you are having after class 12, that will be helpful there. But in your subjective exams, I'm telling you this, until and unless you write everything, you won't get your marks. How the marking scheme is made. Every step is divided with half into half into half into half into half marks, like this in your board exams. And if you miss any step, though you know that you have solved, that's why you are reaching on to the next step. But if you do not mention it in your answer sheets, your marks won't be given to you. in your capacitor circuit, you all knew that C1, C3, C4 were connected in series. So directly you have, or they were connected in parallel, so you have directly added and written. No, in the class, how do we discuss? C1, C2, C3, they are in parallel. Write it, which are in series, which are in parallel. You know, but how will you make the examiner understand that you have understood everything well? And many students have not attempted the question. Most of you, Humam, your paper also. I want you to solve all the entire paper and send me it as an assignment. Faiza and all those, even Rabba, now you can also take the question paper and just attempt it as an assignment so that you have it. Chavez, this goes for you. I don't know why you have not attempted Chavez.
Ma'am, I don't have the question paper.
You have it, Rabba.
No, ma'am. The last question paper I don't have. This Friday I have.
This Friday.
I
Capacitors
attended.
वाला नहीं होगा ना? Yes, yes, Chavez.
Ma'am, I attended the question paper.
Capacitors one you didn't get. Okay, I'll send the PDF again. I'll ask them to send all the, I'll share the PDF.
Ma'am, this Friday way, right, ma'am?
No, this Friday, no. See, this Friday we had just now, this Friday you had the test of current electricity, no, Ohm's law and all these were asked.
Yes, yes.
Before that, where capacitance was also asked, second chapter's test.
Oh, okay.
That you didn't attempt. I'll share the question paper with you all. Faiza, Humam, and Chavez and Rabba. You all send me it as an assignment. Humam, you have to solve it again. Because 20 marks paper, all of you should score. Well, even Shahid, this time your marks have decreased. Though the score is fine, but you usually score more than this. Austin has 18.5 on 20. Shahid 16, Tari 15.5, Rabia 12.5. Yes, Chavez.
Ma'am, how much marks can I repeat for me?
20 marks paper it was. Like the first question, let me have the question paper with you. Permittivity. So permittivity was asked when dielectric was unity. So we have studied epsilon is equal to epsilon naught K. Whatever value of permittivity you have to write. Yes, second question, only Austin and I think, no, Shahid has also answered it incorrect. Only Austin or one more student has answered it fine. Rabi or Austin, I don't remember. I have made you write it separately so many times. When battery is connected, when battery is disconnected, what happens to each? Charge, capacitance, energy, electric field, all these. So when the question came, if battery is disconnected, what happens if the plates are drawn apart? To energy. So energy, didn't we study? Energy increases, right? See, plates get apart from each other means distance C is inversely proportional to D. So if D increases, C decreases. Like this, you have to apply all these questions. Even this question also, you people have not attempted it well. By what factors capacitance of sphere increases if volume is tripled? See, if volume is tripled, we have seen no capacitance is directly proportional to volume. We have a specific formula for capacitance in terms of for spheres. This you people did well, the circuit part. And yes, derivation. Derivation you had to write, discuss the conditions of stable and unstable equilibrium. This Shahid did well, Austin did, and Tarif did. You people have not done even last question correctly. That derivation. Please class, derivations I give, in every exam you have seen I give one derivation at least. This time also, I think drift velocity and that came. So prepare the derivations. They will get you free marks because you know what's the answer. You don't have to perform any calculation. I hope this test all of you have attempted. Is there anyone who hasn't?
Ma'am, that capacitor when I did it.
Travis, you did capacitor one.
No, ma'am. Only the first one I did.
Which one?
Ma'am, the current electricity.
Current electricity one? No. Okay. I'll check yours. Papers I haven't actually received. Once I'll receive, I'll share the scores. Rabba also has attempted this time, no?
Yes, ma'am.
Done with this circuit. Let me know, I'll discuss one more with you. See, Austin, in the third loop, no, I3 we can consider, but we don't have any resistor here with just I3. We have resistor here, but current is not only I3, I2 plus I3. We have a resistor here, so I2 plus I3 minus I1 is there. So when the wire is having just the current I3, no resistor is present. So what we will write? No potential is there if no resistor is present. We are actually writing potential. So that's why we have no I3 in our separate, only I3 is not there in our equation. Got it? If there had been a resistor here, we would have used I3 also.
Ma'am, can you do a little up?
Yes, you were asking something?
Yes, ma'am, can you do a little up? Done, ma'am.
See, this will be, you will find it a little easier because only two loops are there. So I1 and I2 are sufficient. Let's take randomly, let's say from this I1 is coming. Fine. I1 is coming. From here, I2 went into this branch. So what will be left with, we will be left with is I1 minus I2 will flow into this branch. I1 minus I2 it will flow. This is the same wire. So again in this branch also, I1 minus I2 will flow. I1 minus I2 plus I2. I2 gets cancelled. We have I1 back. You can check also. See, again we are getting I1. So division was easy. You can take anything as I1, I2. Ultimately, I have discussed branch should have the same value. Let's take it as randomly. Let's take it as randomly. Let's say this is clockwise. Clockwise means this. This is clockwise, right? I am considering P, Q, R, P. P, Q, R. Never write class just P, Q, R. If you only write PQR, your loop won't be closed. So this is PQRP. Until and unless you mention this starting letter back, your loop won't be enclosed. Fine. Now, let's just start with anyway. Let's say from here, we are going clockwise, no? So we are moving opposite to the direction of current. Yes, current in this branch is moving towards the left. So, and we are moving towards the right. So opposite, this is the direction we are moving. This is the direction we are moving, like this. Is the cursor visible when I'm showing this?
Yes.
Are you all able to see this cursor? Okay, then it's fine. Then it's fine. So this is the direction. You can notice current is flowing here. We are moving here. Third equation. Raba, I'll show you. So this becomes, if we are moving opposite to direction of current, that means plus I1 into 200. Yes, I into R, that is potential I've obtained. Next potential, we are moving opposite to direction of current. Opposite to direction of current, opposite to direction of current. So this will also be plus 20 I2. Current is I2, resistance is 20. No resistor is there, battery is there. See, this is which case? Current is coming from positive terminal. This is positive, negative. So this is the same case as previous. So again, this will be plus 5 equal to 0. And in this, solve all these equations, I1, I2, I3, the answer won't, this is not the answer. You have to find out the values of I1, I2, I3. But this question is easy. This question is better because one equation is this. This is also a simple equation only. Let's take the same direction. You can take the same direction for this also. So again, I'm moving clockwise. Clockwise means this. Firstly, naming of the loop. Loop is PRSP. PRSP. This is the loop. I am moving along the direction of current. Current is also moving upwards. I am also moving upwards. So negative minus 20 I2. Coming here, opposite to the direction of current. Current is moving like this. I am coming like this. Yes, this is how I am coming. So this will be positive. Plus 60 I1 minus I2. Then here, this again, we are in the opposite direction. Yes, we are moving like this. Current is towards moving right. We are moving towards left. So what is the resistance? What will be the sign convention? Plus, because we are moving opposite. Potential V is equal to I R. R is this, I is this. And look at this case. This is a different case. Current is coming from negative terminal. This is positive, negative. Current is coming from negative terminal. So minus 4 equal to 0. Two equations you have. Two variables you have, find out I1, I2, all the current you will get. You have the current, you can find out anything then. Note down this question. Keep on texting me done as you complete so that I will know how many of you have written. And any doubts you can ask. So I think this is clear to you or to all of you? Humam, Tarif, it's clear to you? Rabia. Oh. Yes, second equation, I can explain it again. See, in the second equation, we are moving clockwise, right? So when I'm moving clockwise, I am moving with the direction of current, same direction. Same direction is negative. So minus V is equal to IR. So I into R minus 20 I2. Now coming to this branch, we are moving, since we are moving clockwise and this is anti-clockwise, opposite direction. So opposite is positive, 16 to I1 minus I2. We are again moving opposite. So plus 2 into I1 minus I2. Current in this branch is I1 minus I2, no? So we'll consider current into resistance, that is voltage. And this is the case from negative terminal. See, like here from positive terminal, current was coming. So we took it as positive. From here, negative terminal current is coming. So we will take it as negative. Now clear, Abba? Or should I repeat once more?
Clear, ma.
No, Tarif. See, why batteries do not have currents? Because we are writing the voltages. So with the battery, you already have the voltage. With the resistors, you don't have any voltage. So that's why we use Ohm's law. V is equal to IR we apply. That's why with the resistors, we were having currents because we have to ultimately write down the potential. What was Kirchoff's second law? It said that net voltage is zero. So ultimately, we have written net voltage is zero. So here already voltage is mentioned. So no need to apply current and resistor. Right, directly you are having voltage. That's why we will write voltage as it is. But when we are talking about resistors, their resistance cannot be put. But when you multiply resistance to current, you get voltage again. That's why. All right, Tarif? Done, all of you. One last thing I want to discuss. Wheatstone bridge balancing we did, but remember once I've told you that we'll do the derivation, how the balancing condition is obtained, that I want to discuss. That is the last thing for today. If you people have completed, we can move on to this. Only Austin has let me know that he has completed. Austin. Apart from Austin, all of you have done or not?
Yes, sir.
Achha, all of you have completed. Okay. Let's discuss then this Wheatstone bridge also. Let's discuss. This would be the last topic for today. And if this is asked, see in your circuits, Wheatstone bridge we have discussed. You know how to solve it. That becomes your easiest question. But balancing of Wheatstone bridge is actually included in your derivation part. So it can happen that Kirchoff's laws are asked, or what is derive the balancing condition for Wheatstone bridge. If it is asked, just do as I will be discussing with you, exactly like this, because we will solve this with the help of Kirchoff's law only. This is the circuit we have. This is how we start the questions. Let's say the entire current is I, which is coming. We make this as let's say current is coming I1. I1 is moving from here also. I is coming, not I1. Let's say total current, I am taking this as I. This is the total current. So ultimately I have to get I back here. Let's say this is I1. In this branch, I1 is flowing. So in this, what will be left? From I1 has gone. So I
minus I1.
Yes, I minus I1. Very good. In this branch, this occurs. This is the galvanometer. Let me name this as IG. Why? You will know. This will help. Let's name this as current of galvanometer IG. So I1 was coming, IG has gone. So again, I1 minus IG is left. So this branch is having I1 minus IG. Now I minus I1 is coming, I minus I1 plus G
plus IG.
IG. Very good. So in this branch, I minus I1 plus IG is being added. See, if we add these, are we getting IG back? Say yes.
Here IG can flow from D also, right?
Yes, Chavez, what are you saying?
Like IG can flow from G also, D also, right? D point.
Yes, IG can go from any point. It can move from D to B also. You can take randomly. But since this is a derivation, so if derivation comes, then try to follow all these exactly, the steps exactly for the derivation. Otherwise, no, in this, if you get stuck, that's it, then it becomes difficult. But you can take any. I'm telling you, no, you can take X, Y, Z also as your variables. Ultimately at the end, your branches should have the same value of current. It doesn't matter whether I'm having 3 currents here. Let's say someone of you has taken that current is let's say this current in this branch is I1 only. Doesn't matter if your I1 is coming same as this value, answer is right. So that you can take. Now see, if we add them, I1 IG, they'll get cancelled. We are getting I back. It means we have distributed the current perfectly. If no, sometimes you are seeing that from here you have started I. On distribution, you are getting I minus IG. It means something you have done wrong here. Ultimately, you should get the current back. Your circuit should be completed. So that is a hint with which you can solve it. Now solving, let's A, B, D. Let's go here. Let's solve this. A, B, D, A. This is the branch. So A, B, D, A. Like this, I am moving. So from A to B, I am moving from A to B. So I am moving along the direction of current, same direction. So negative I1 into R1. Potential I've written coming here. So this is resistance of galvanometer is G, current is IG. So I'm moving along the direction. So minus IG into G. And last, this is I am moving opposite direction. So this will be plus. This will be plus I minus I1, and this entire will be equal to 0. Right? This is solved. Fine. Let's take this. This is one thing. Let me tell you, class, before that. If your bridge is balanced, balancing condition we are discussing. No, if the bridge is balanced, then your current through the galvanometer is 0. Ig becomes 0 because we have studied already that potential difference is same. So current is 0. So everywhere put this becomes 0. So what your equation you are left with is minus I1 R1 plus, I'll solve this. I'll not leave this time the equation because I have to find out the answer. This is 0 minus I1 R1 plus R3 I minus I1 is equal to 0. So how can I write this? R3 I minus I1 is equal to I1 R1. This is the final. Now I cannot solve it more. First equation. I'm solving this because this derivation we'll find out the final answer as well. Second loop is B, C, D, B. Second loop is B, C, D, B. So let's move clockwise. Let's say if we are moving from here, same direction. So it would be negative. Resistance is R2, current is I1 minus Ig. So this becomes minus R2, I1 minus Ig. Yes. So coming to this, we are moving again opposite directions. Opposite is always positive. So plus we will take and resistance into current. So this becomes plus R4 I minus I1 plus Ig. Lastly, this we are moving. We have moved like this. This is the last branch. We are moving opposite direction. So plus we will take Ig into G. Plus Ig into G is 0. We are discussing the balancing condition. So this would be 0. This would be 0. This will also become 0. So what are we left with? See why? Because understand, if your bridge is balanced, we are discussing the balancing equation only. Ig becomes equal to 0. We are discussing this only. What are we left with? Minus I1 R2 from here plus R4 I minus I1. This is 0. So this is equal to 0. R4 I minus I1 is equal to I1 R2. Second equation I have obtained. Let's divide 1 and 2. Divide both the equations. Divide 1 and 2. Divide these two equations, both these equations. So this becomes I1 R1. I1 R1 is equal to R3 I minus I1. This is the first equation. And what is the second equation? If I'm dividing them, this is I1 R2. This is R4 I minus I1. This gets cancelled. This gets cancelled. We have obtained the balancing equation. Remember, this was only the equation which I used to tell you. R1 by R2 is equal to R3 by R4. So if a proof comes, you can use this. If the question directly comes, you can directly apply from here. Okay, so this is a derivation. It can come in your exam. Note it down. Text me done once written. Any doubts you have, you can ask. That completes with Kirchoff's law. One last class I need tomorrow. Monday we have our regular class. Tomorrow we'll complete with this lesson. I just want to discuss cells with you because some questions are there with cells only. Mixed grouping, parallel grouping, series grouping. That I'll do tomorrow.
And will this derivation come for 5 marks?
Yes, you're asking something?
Like, will this derivation come for 5 marks?
Yes, yes. If the derivation comes, it will come for 5 marks, a full-fledged question. If it comes, it will come for 5. Kirchoff's law are usually for longer marks. 2 markers are never there with Kirchoff's law. If 2 mark question is there, that means you have to state the law. So remember the laws as it is.